The transformative impact of cloud is undeniable to both business and IT. More and more, this movement is trending towards a multi-cloud environment. But what guides a company's cloud strategy? That's a question Kelly, an IT director, and her colleague Alex are debating over coffee. Kelly tells Alex that their cloud strategy is guided by the need to develop new applications while protecting their existing application portfolio. The firm needs the flexibility to develop any type of app, deploy that app to any cloud, and deliver it to any device. Alex worries that delivering this level of flexibility will lead to a lot of complexity. And won't there be an increased risk? That's a legitimate concern, Kelly agrees. But applying consistent infrastructure and operations to multi-cloud environments makes it possible to put common management policies in place. There are also new technologies that can secure apps across clouds, promising even better visibility and threat protection than we have now. But what about our existing apps and systems? Will we be able to extend them to this new environment, Alex asks? Our cloud strategy provides a common operating environment that makes it easy to manage all our apps and services, Kelly answers. We're also planning for new technologies like AI and machine learning. Alex is starting to see how a multi-cloud strategy could help the firm become more agile. I just had a meeting on our growth goals for next year, and they're pretty ambitious, he says. Kelly smirks. Bring them on. Learn more about how VMware can help you meet the challenges of moving to a multi-cloud environment.
VMware Tech Talk series. This is Mohammed Olayan. I'm AVI Solution Specialist Engineer with the VMware, and in today's session I'm going to talk about AVI, the Multi-Cloud Application Services platform. Just to give you an idea about this webinar before we start, VMware decided to start it to address the current circumstances and to help you learn the best practices to achieve success in your business continuity. I hope that you attend the previous sessions with our team. There are a lot of interesting topics they discussed. And definitely there will be more webinars to follow, so stay tuned. So back to the main topic, how AVI help companies to deliver their apps easily and efficiently in a multi-cloud environment. And look at the most recent reports about the multi-cloud. We find around 80% of the enterprise are looking for multi-cloud. And the majority of them, they consider hybrid cloud as an option, which typically means on-prem with one or more public cloud. But again, there is a question here. What's the reasons for them that they choose the hybrid cloud? Definitely there could be different or multiple reasons for them. They prefer the hybrid cloud. Could be the cost, that they are looking for better availability, the portability of their apps, reducing the lock-in to vendors, or maybe the time of deploying these apps. So all of these are valid reasons for them to go with the hybrid cloud. But I think the time of deploying apps become one of the most important reasons for them because companies today are under huge pressure of the increased number of apps they have. Look at your company, for example, today and compare the number of apps you use it with what it was like 2 years or 3 years back. Definitely today we have more apps than before. So these apps become the main driver for these companies to start their digital transformation journey. And now, instead of just being on-prem, they are in a hybrid cloud, which definitely mean huge changes or major changes in the environment where they deploy their application. And what usually happen, all of these changes they made usually falling on the back of the same team, which means that now this team, they have significant increase on the apps and significant increase on the changes on these apps and a multiple environment, which is greater complexity for them to do an operation and deployment for these apps across these so many of different environments. So in order for them to simplify that, what the company did, they tried to build much more flexible and scalable private cloud first to simplify the operation of these private clouds. And what they start to do, they start to virtualize this environment. They virtualize the compute, storage, and recently the network. And NSX is one of the great examples how did we virtualize the network layer. And by doing that, now they have modern software-defined data center. And by building that foundation, definitely they simplify the operation of their cloud and they make it more automated as well. And it could be like single point of control and operation for all of these different components of their data center, which is a great approach, by the way, to reach up to that level. But when we look at the other major component of their application delivery, such as the load balancer, this component, and I'm talking about the traditional load balancers they have, this component become the blocker for this digital transformation journey they started, or the blocker for that foundation they built, because these load balancers in the past was working great for them, for the architecture that it is designed for. And I'm talking here about the legacy architecture they have, or the legacy data centers they have. But now we have much more modern data center. And there was no significant actually changes on the load balancers itself to be more simple or more scalable and flexible as it's required today on the modern data center, as well as on the hybrid cloud as well. So for these customers, when they said, okay, we're going to go with a public cloud to simplify all of these things, we have a ready platform that we can simplify the deployment of our apps, and we can minimize the time of building these apps or deploy these apps. So when they take part of their workload to the public cloud providers, they would definitely prefer to consume the cloud native load balancers rather than the traditional load balancers. And after some time, they will increasingly find that this load balancers does not have all the required features that we are looking for. It's not advanced enough. And they could face another issues, which is the portability of these load balancers. These load balancers is not portable, so you cannot move it from one cloud to another, or you cannot move it back to your private cloud, because each one of them is only designed to work on that platform or that public cloud platform. So there would be no way actually to take these load balancers across these clouds or across the multi-clouds they have. So when we look at the other side, we find that we are having in our prem virtual traditional load balancer, and it is rich with the features. It includes everything we want for the load balancing. And we have an option to take these load balancers to cloud. So we can move this virtual load balancer to our public cloud anytime we want. But when they take these load balancers to cloud, they realize that these load balancers does not have the same capability of the cloud native, and it is not flexible. It's not elastic load balancers. Does not have all the features. It could have the features we want, but it doesn't have the required level of automation that we want on the cloud native load balancer. So in these both options, we have to trade off some features. When we go to the public cloud and we use the cloud native load balancer, then we have to trade off the advanced features, the portability, and definitely the visibility as well. And we will go with traditional load balancer. Definitely, we are going to trade off the cloud native capability, which is really challenging scenario and situation. And there was no answer for all of these challenges we have until Avi came and bring the best of these both worlds, giving customers the same capability of the cloud native load balancers and the same capability of the traditional load balancers within the same solution. And I'm expecting the next question here would be like, how Avi do that? And here is the answer for these questions. What Avi did, Avi built or apply modern software-defined architecture. And first thing they do, they decouple the control plane from the data plane by split it into two parts or two software instances. Control plane, or centralizing control plane first, and distribute the data plane layer. The control plane, or what we call it the controller, is managing the life cycle of this distributed data plane, or what we call it the service engine. Service engine essentially is the load balancer itself. And the beauty of this architecture, we are still having single point of control for all of these distributed data plane we have. We can deploy this data plane we have in a different environment, which will allow us to have the same consistency on the multi-cloud environment. Same controller will be able to manage that distributed load balancers across different environments. These load balancers can sit in a bare metal, in a virtualized environment, containerized environment to work as an ingress load balancer with a Docker, Mesos, or other containerized environment as well. Or at the same time, we can use it in a public cloud. And these load balancers, since it's controlled by the single point of control, the controller, and since it is split from the controller, it's a very elastic fabric. So the controller can spin up a new load balancer or service engine wherever needed, can scale out, scale in, based on the situation and based on the need that we have. So this is not all the benefits of this architecture. There are other things. And as you may know, the load balancer usually sits in a very strategic position on the network. It's very close to the applications. And Avi leverage this architecture where we can have the service engine sit very close to our apps or in the traffic path to these apps, and at the same time use the service engine capability to provide telemetry to the controller using around 600 metrics. And since the controller is the brain of the solution, the controller will use these metrics to perform some actions, like run predictive auto-scaling whenever needed, or it could even perform self-healing for the service engines when it fails. So this is part of the benefits of this telemetry on the controller, but definitely there is other benefits as well. So when it comes to troubleshooting our apps, so rather than just running traffic capturing for these applications and look at the details of like client-side details and server-side details and take this capture to third-party software to look at the details of the traffic there. So we can use this telemetry to make the troubleshooting easier, where we can where the controller log every single client request. It's including the client information, load balancing information, and the server side information as well. And all of this information is a real-time information provided by the service engine to the controller, which definitely will make the troubleshooting for the application performance issues or for any problem with these apps very easy and much more efficient than taking this traffic capture somewhere else and look at it and then try to find out the issue. So the controller uses 100% REST API calls to the service engine whenever one need to perform any task. So at the same time, controller can invoke API or native APIs with a different platforms such as Azure, Amazon, Openstack, which will automatically allow self-service for application and developers. So they don't really need to know exactly how to deploy in this environment, since the controller will use this native API calls to deploy the service engines in this different environment, which will make the load balancing deployments very easier for them. And that means they can run load balancing for multi-cloud environment, and still they are centralizing the control and the administration of these load balancers from the same control. So there are very important points to know that this solution fit with the VMware solutions, but at the same time, it run and work with the other on different environment as well. So since it's part of VMware, it will have deep integration with the VMware solutions such as the NSX, EUC, Tanzu, and other VMware solutions. But at the same time, this architecture of Avi will provide the same consistent load balancing across other solutions as well. So you will have the full capability of the load balancing, web application firewall, GSLP, analytics platform, ingress load balancing for the containerized environment, within the same solution. And that simply means this will allow customer to deliver any app at any cloud and for any platform as well. So running our apps and AVS solution in a different environment, that doesn't mean that you have to sacrifice some features when you run it in a hybrid cloud or in a multi-cloud environment. So you have the same functionality of these load balancers or of that application delivery platform into your private cloud. At the same time, you will have the same functionality in a public cloud. So you don't have to sacrifice, for example, the security functions, the visibility when you take AVI to the public cloud. So looking at the features of this platform, actually, as you can see here on this slide, it's split it into two parts. On the left side, this is what the customer usually expects from any load balancer. So you will need, I'm not going to go through all of these features, but you will need layer 4, layer 7 load balancer, GSLB, auto scaling, and definitely you need full security functions as well. And this is what AVI have in the security. It is full security stack, consists of SSL visibility, rate limiting, layer 3, layer 4 access list, and web application firewall as well. On the other side, this is AVI unique features. Full analytics platform, including network and application performance monitoring, scoring for the application servers, and full visibility into your applications. So this is what we have discussed previously regarding the telemetry feeds by the service engine to the controller, and how that can be used to simplify the troubleshooting, or can be used by the controller itself to perform some actions. Other things is the centralized management for the solutions, where we have single point of control for all of the distributed architecture or multi-cloud environment. We have full multi-tenancy solutions, full RPAC solution, built-in IPAM and DNS solution can be used for assigning or allocating the IP addresses of these service engines. So last thing, I would like to take a closer look at the web application firewall, since the web application firewall today is an integral part of the application delivery. And whenever we deliver the apps, we want to make sure that we have the required security level to secure that application from the web threats. And as you may know, the web application firewall is a little bit complicated or a complex technology. And most of the customers, they have some challenges when they deploy their web application firewall. They have like a huge number of the false positive, and they don't know what the action they have to take when they have this false positive. They have very, very complex way to build the policies for their applications. They could face performance issues into these apps when they enable the WAF. And think about it, how it would be more challenging even for them when they enable web application firewall in a hybrid cloud environment. So how AVI help actually to simplify the web application firewall and to ensure that we have efficient web application security? The AVI architecture itself will help customers to overcome all of these challenges. So AVI will have a centralized policy builder for their web application security. We'll leverage the visibility, which is a key thing to build the policy for the applications. The solution itself have enough scalability and elasticity to scale whenever we face any problem or issue with the performance of that web application firewall. So how AVI do that? This is AVI web application firewall pipeline. So first thing, we have a whitelisting where we can define whatever we know that it shouldn't pass through the policy, and it should go directly to its destination. The other thing is the positive security, which is very important part, where we learn the components of the applications that can be done into two different ways, either manual by the admin, or it could be using third-party DAST solutions. And the third thing is the signatures of the systems, where we can here scan all the signatures and update all the signatures automatically as well. So this is just a quick look at the WAF capability we have as a part of the solutions, and how the architect of AVI will simplify the web application security policy in a hybrid cloud architecture. So to get more information about today's session, here are a few useful links you may follow. And yeah, that's all for me today. I hope that you find today's session informative. And if you need more information, please contact us. You can reach out us by clicking the Contact Us link below. Thank you.